rationals. So rationals, last year in grade 11 you did simplifying rationals, adding rationals, subtracting rationals, multiplying, dividing, and solving rationals. This year we look at rational graphs, and it's helpful for calculus as well because they'll talk about rationals in calculus. So we're going to look at the very first basic ones. So we're going to look at y equals 3 over x minus 2. Now you either have to put that into your calculator as the fraction button, and then 3 over x minus 2, or you have to put the x minus 2 in brackets so that it knows it's in the denominator. So everyone type that into your calculator. My one that I had from the computer has now expired. I opened it up today and it's like, $2. I'm like, so I have to get more.
Oh, you could have spent like the $200 that we got for our mental health.
No, I have the thing. I just need to get them and board.
Wait, you got $200 for mental health?
All the teachers did.
For what?
To improve stress.
Oh, well. They gave money.
Don't worry, Miss Lepp, your class is not stressful.
What
are you
No, actually, your class is like always stressful.
We spent this in a white.
Oh, sorry when I was crying your class. We gotta talk about that. No, I don't know.
Nothing yet. Can you go into your y equals and can you type in 3 divided by bracket x minus 2?
It's like...
Yeah. So it's going to get asymptotes. There's going to be asymptotes in it. So what's going to end up happening is you're going to get a graph that has a horizontal asymptote at y equals 0. And you often won't be able to see it on your calculator. You'll see the graph curving there. And then a vertical asymptote at 2. So something like this. Correct?
Yes.
Then if we want to sketch any more of it, we really can go to our calculator and do it. But if we pulled away our calculators in calculus, we could pick any x values on the left of it and like find the y's, any x values on the right of it and find the y's. So let's say I put in into my table, I put in 1. So then I'm going to get 3 over 1 minus 2, which is 3 over negative 1, which is negative 3. I'm just plugging in 1 for x, right? So now my coordinate would be at 1 and negative 3. I could plug in 0, and I get 3 over 0 minus 2, which is negative 3 over 2, which is negative 1.5. So I have 0 and negative 1.5. And then I could plug in negative 1. 3 over negative 1 minus 2, which is 3 over negative 3, which is negative 1. And then I could plug in more values, and what would end up happening is you'll see that there's a curve like this. I would need more values to make it more accurate, correct? But I'm just getting the curve. Now, with rationals, there'll be, when it's a basic one like this, you'll have one in the bottom, and then the other one will be in the top. You'll see that in your calculator a lot of the time, too. So say I put in, now the other side, I can put in 3. So I'm going to get 3 over 3 minus 2, which is 3 over 1, which is 3. So I have 3, 3. And I plug in 4. I get 3 and then 4 minus 2, which is 3 over 2, which is 1.5. And then say I plug in 5, I get 3 over 5 minus 2. That's a 1. That's a 3. No, it's a 2. This is a 3. 3 over 3. Is it the weekend? No? Not so much? My brain's there. Okay, we're at 5 and 1. Okay. Then run along here. Anyone have any idea why there would be an x that doesn't exist at 2? Grade 11 would have taught you why.
Because wouldn't you just be dividing by 0?
You'd be dividing by 0, and we're not allowed to, correct? So our vertical asymptotes what you can do is you can just take the denominator x minus 2 and set it equal to 0 and figure out then from there what x value would get you equal to 0, correct? So here it would be x equals 2. So we know for this one we have a vertical asymptote at x equals 2. Now how the heck should I figure out the horizontal asymptote? Well, this is a little rule. So if you look at the numerator compared to the denominator here, the numerator is a smaller degree than the denominator, isn't it? The degree of the numerator is 0, because we could write x to the 0, couldn't we? And this is x to the 1. So the degree of my numerator is smaller than the degree of my denominator, correct? In calculus, they'll show you why this rule works. In Math 3-1, you just trust me. So, when the degree of the numerator is less than the degree of the denominator, your horizontal asymptote, and it's horizontal because x equals always cuts horizontal and y equals always cuts vertical, right? That's a lie. X equals always cuts vertical and y equals always cuts horizontal. So this is a horizontal asymptote. And remember, the vertical ones come from the denominator, right? X can't equal blah. The vertical asymptotes are going to come from our rules. And the great thing about calculus is very soon you're going to see why these rules actually work through limits. So the horizontal asymptote is y equals asymptote, because y equals cuts through the y-axis. So like if I had like y equals 3, that would be where it would be, correct? If I had y equals negative 3, it would be down here. So y equals lines are always horizontal lines, and x equals lines are always vertical lines, right? Because x equals cuts through the x-axis vertically. Horizontal cuts this way. This one will always have a horizontal asymptote. Where was our horizontal asymptote on? On 0, right? On the x-axis. And what's the equation of the x-axis? Not just 0, it's y equals 0. So whenever your numerator is a smaller degree than your denominator, you will always have an asymptote on the x-axis. Okay? So let's look at another example. We're going to look at y equals negative 2 over x plus 4. I want you to do a quick little sketch, and you can use your calculator for that. I don't really care. And I want the asymptotes. Okay? Quick little sketch. And when we looked at this one, it was almost kind of like it was in quadrant 3 and 1. Now I know it's shifted, but it was in like quadrant 3 and 1, correct? This one's kind of in quadrant 2 and 4. Do you see that? Look at right here. There's a negative. When you have a negative leading coefficient, that's a negative in front of the y, it actually is a reflection in the x-axis. So instead of it being a 3 and 1, it actually reflects the graph being 2 and 4. So that's how you can tell if you're a little right or wrong too. Okay? Now I know that this here is going to get me my vertical asymptote. And it's going to be at x plus 4 equals 0. Now you don't have to show all these steps because this one's kind of easy, but good practice. So x equals 4 is my vertical asymptote's at. My numerator is a smaller degree than my denominator, correct? So my horizontal asymptote will be at y equals 0. So if I go to sketch it, I have an asymptote here. I have an asymptote here. And you always sketch them. And then I can pull values off my table if I really want to. So I can go like negative 9 and 0.4. and then negative 8 and 0.5, negative 7 and 0.6, negative 6 and 1, negative 5 and 2. And then I can run a graph along there. And then I can look on the other side of negative 4, negative 3 and negative 2. Negative 2 and negative 1. Negative 1 and negative 0.6. 0 and negative 0.5. Okay, join me. There we go. And then it's going to run down here. And it's going to run along that whole thing, but never cross it. The asymptotes are like an electric fence. A cow would walk across them and walk and touch them, and they want to get the grass, but they can't get them. They just keep walking. You're just walking your cow along the fence. That's all that's happening. And then the cow keeps going, and it curves, and it's like, boom, more grass. And it's like, no, not an electric fence. That's what's happening. Cow, it's just electric fence walking. Okay, they don't do that on a rational graph. The cows are good cows, and they stay in the fence. The cows should wear rubber boots?
Yeah.
I'll give them, I'll tell them about that option, a rubber bodysuit, and then they can just walk through. They go through anyways, they don't care. It keeps them out for a bit, but then they kind of figure out the yeah, especially if they're really hungry. And there's grass in the ditch, and in your field there's not.
They always want to, but they can't.
Yeah.
Especially if it's not like
Oh, the having to go get cows at random times to be like, John, your cow's. I'm like, no! Worst case scenario, cows aren't bad. Cows you can kind of get back in. We had buffalo once.
My dad won't let me get buffalo.
No, and he should not, because buffalo follow each other whether there's fence or not. So you have to, like, when you bring your buffalo back, you have to bring them back slowly. Like, because if one of them's like, I gotta go, they bust through everyone's fence, and then you're fixing all the people around you's fence because they just run through it, because that's why buffalo jumps worked in the day.
My bull does that. We had a bunch of open heifers in my neighbor's house.
Oh, bad. Not good.
Jumped the fence and bred them all. It was lovely.
Hell yeah.
There's your mouth.
Did you have to do all of the cow checking when it was November and freezing because your bull got into
You don't start calving until for like another.
I know you don't. But did you have to do your neighbors checking of the calves because your bull got in them too fast?
Oh no, because they just come for the summer, and then they leave. So that's wrong.
They didn't know any better?
I don't know.
Oh,
We told him, and he was like, "Oh, that's whatever."
Okay.
No, it's not really whatever.
It's not. It's like that is like December, really cold calving. That's what that is. That is evil.
That he wasn't concerned about it. But
It's okay.
I don't know.
That never leads to good calving. That leads to really cold, wet, dead calves. Yeah. Okay. Oh my goodness. 3 over x squared minus 4x minus 5. What did I just do? I did not ruin your life. I made a quadratic in the denominator. What is still the same though? The numerator is still less than the denominator. So what do I still know? Y equals 0. I know my horizontal asymptote is y equals 0. What are you going to have to do to this denominator? Factor it, and then you're going to get 2. Okay, do that in sketch. Go. Okay, when we factor this one, we're going to get x minus 5, x plus 1. This one's going to get me x equals 5. And this is going to get me x equals negative 1. So that's my vertical asymptote. So we have y equals 0, which is actually just the equation of the x-axis, and then negative 1, and 5. How do I sketch the graph then? Put it in and look for what? Look at my what? Your table of values, right? Because you can just pull values off at second graph, right? You can pull all the values you need off of there. So you can go like -4 and 0.1, and then -3 and 0.18, and then -2 and 0.4. So it's going to run along here and curve up, right? Then we go up to our error 0 and -0.6. And 1 and -3.75. 0.333. 3 and -3.75. 0.6. So it curves and goes down like this. And then 6 and 0.4. 7 and 0.18.
We just add that.
Yeah.
Okay,
I was in that.
does that make sense? How you get the difference? Okay, now what happens if I make them the same degree? So what if I give you this? Y equals 2x plus 1 over x minus 4.
Isn't it just 5 plus 1?
Nope. What happens if I give you the same degree? You can still give me the vertical asymptotes really easy, because that hasn't changed. What's my vertical asymptote?
4.
4.
Yeah.
Yeah. So it's just the leading coefficients. So of the largest degree will get you your horizontal asymptotes. So if this is x to the 1 and this is x to the 1, it's going to be 2 over 1. Now sometimes they'll write it in a weird way so you fall for it, but they'll go like 1 plus 2x over x minus 4, and then people will tell me it's 1, but it's not. It's still the leading coefficients of what's in front of the x's. So this would still be a 1, this would still be a 2, so it would be 2 over 1, right? So this would be my horizontal asymptote. Of y equals 2 over 1, which is just silly, or y equals 2, right? Do we agree? Just the coefficients. So I'm going to give you this one, and you're going to tell me what the vertical asymptote is and what the horizontal asymptote is. So we're going to have y equals 2 minus 3x over 4x plus 1. I want the horizontal and the vertical asymptote. What is my vertical asymptote? Vertical is the x.
-1/4.
Yeah, 4x plus 1 equals 0, 4x equals -1, x equals -1/4. So vertical is always your denominator one, because vertical lines are always x equals lines, horizontal lines are always y equals lines. Then the horizontal asymptote is the leading coefficients when they're degree 1. So this is degree 1, this is degree 1. Then this, -3/4, will be my horizontal asymptote. Right? And if I went to sketch them, the x equals -1/4 would be like here. And y equals -3/4 would be like here. Because y equals our horizontal lines and x equals the vertical lines, right? And we know how to sketch these from our table of values because we did it last year with reciprocal graphs. Like that should be the easy part. Go on there, pull out some values and sketch it, right? Hardest part is just sketching the asymptotes accurately. Okay, this is new. So, what if I give you this? So let's do squared minus 5x plus 6 over x minus 3. So the last one, those ones were the degree of the numerator and the denominator were the same, right? This one, the degree of the numerator is what? Yeah, greater than the degree of the denominator. What can I do to that numerator? I can factor it. So we're going to get, what multiplies to give me 6 and adds to give me negative 5?
Positive 1.
Nope.
1. No. Negative 1.
Nope.
-3 and -2.
Yeah. X minus 3, x minus 3. You just fell for it if it was a minus 6, that's all. And then an x minus 3. What's going to happen here? Sorry? The x minus 3s are going to cancel. The moment you go to cross them off, it's no longer a vertical asymptote. You know, some people want to tell me the vertical asymptote is 3 because x minus 3 is in the denominator. The moment those cancel off, it's not a vertical asymptote. It's actually a point of discontinuity. And I'll show you what it looks like in your graph. So this cancels off and this cancels off. We agree? So the moment that something cancels off, you have a point of discontinuity, which in calculus is called the jump discontinuity. Or no, jump discontinuity is when it spreads. But we call it a point of discontinuity. A point of discontinuity needs to be a point, a coordinate, correct? We know what the x is. What's the x of this coordinate? 3. It's whatever I crossed off, right? So the x is 3. Anyone have any idea how I would get the y?
Yes.
Not a good idea. No, we know it's 3. What can we do?
Put 3 in for x.
Put 3 in for x in the, not the original,
No, just in the normal, like the new one. Like
in the new one, in the simplified one, in the one where I got rid of the point off. And the reason why, if I plug it back in here, I'm going to get a 0 in the denominator, correct? If I plug it back in here, I've gotten rid of the issue of 3, and then I can plug it in and find out what the y would be that corresponds to that point that doesn't exist. Because the point of discontinuity is an open dot. It's a point that doesn't exist on the graph. So, I would, to find this, I would fill it into y equals x minus 2, the simplified form. And I would get y equals 3 minus 2, so y equals 1. So if I go to sketch this, this is what I know. I know that there aren't asymptotes on here. If it cancels off, it's not an asymptote. If there's nothing left in the denominator, it's not an asymptote. So I know that there's an open dot at 3, 1. So I go to 3, and I go to 1, and I make an open dot. It doesn't exist there. We agree? What equation was left after it canceled off? Y equals x minus 2. That's actually all that's left. Y equals x minus 2. So I just have to sketch that graph. So how do I sketch the graph y equals x minus 2? My y-intercept is negative 2. And then my slope is up 1 over 1. Because of the 1 over 1. Up 1 over 1. Up 1 over 1. Up 1 over 1. Can't go to that dot though, right? Up 1 over 1. Up 1 over 1. Now say I'm stuck. Say I'm like, I don't remember how to draw a line. I can still draw the point of discontinuity, right? The open dot. I can put the original into my calculator and it will give me those points for me to sketch it, right? So type this into your calculator. Type the original in. Make sure if you're not using the fraction button that you're putting brackets. Type it in and see what it looks like. Now Now, just so you know, your calculators believe that all graphs are continuous. So, like, in the old one specifically, when they draw them, they'll, like, even sketch the asymptote with it. Because they try and make the graphs all continuous. If you look, it looks like a straight old line without a gap, right? It looks like just a line, yes? But if you go second graph, and you go to when x equals 3, what do you get beside it for your y?
Error.
Error. So there is an open dot there. Okay? I'm going to get you guys to try this one. So what if I give you 3x squared? I'll go f of x equals 3x squared plus 4x minus 4 over x plus 4. I want the point of discontinuity and a little sketchy sketch. Okay? Bottom. Yeah, it doesn't work. I don't think textbook for maybe a question doesn't work. It just needs to be x plus 2. Yeah,
Like a,
it was wonky.
yeah, one side of the roll.
Yeah, that's more, like, you get slant asymptotes and stuff like that. But that's calculus, not here. What cancels? X plus 2. The answer was nothing a few seconds ago because it was stupid. The x plus 2 cancels. So the moment that I cancel off something, I have a point of discontinuity. And it is at -2, and we have to figure it out. F of -2 technically equals 3 times -2 minus 2. So it's -8. Do you want to know why I love rationals?
No.
Because the domain and thank you, I'm glad you're here. The domain and the range are literally just can't equal those. Because the domain and range equal everywhere else but this open dot, or where these asymptotes are. They're everywhere else, right? So you did these last year with reciprocals. The domain would just be x such that x can't equal -2 XCR. Because it equals everywhere else. All the rest of the reals but -2. And the range would be y such that y can't equal -8 YER. All right, we have one last thing to go over, and it encompasses points of discontinuity and asymptotes. So what we've had so far is when something cancels off, the whole denominator went away, correct? What happens if they're the same degree, but only part of it goes away? So say we have f of x equals x squared minus 4x minus 5 over x squared minus 3x minus 4. You factor those two. It needs to be, I'm going to get, on the top, I'm going to get x minus 5, x plus 1. And I want this to be, that'll be x minus 4. This will be x minus 4x plus 1. Okay, we're good. I was scared of my made-up question, but it was okay. So it factors, and what's going to happen? The ones are going to cross off. And the moment that something crosses off, what do I have? Right. Did the denominator fully go away though? No. Watch this. So I'm going to have f of x equals x minus 5 over x minus 4 is technically what I'm going to have left over once these go away. Right? And what is this? It's irrational. It's what we just did. Correct? So before we even do the points of discontinuity, let's just discuss this one. What would my vertical asymptote be? X equals 4. Yeah. The degree of the numerator is the same as the degree of the denominator, so what would my horizontal asymptote be? Nope. When the degree of the numerator is smaller than the degree of the denominator is 0. Yeah, the coefficients would be 1 divided by 1, which is 1. So not only does this graph have an asymptote, a vertical and a horizontal asymptote, which I'm going to sketch down here. It also has a what? Point of discontinuity. Yeah, yeah.
If like, I know it might be like the same for every question, but if you like did the top number divided by the bigger number without the simplified version, like would that be? Like I know for this consistent.
I don't know what you're saying.
Never mind.
She means like the x squared over the x squared.
Like what do you always do is simplify?
Yes. But had you not done the simplified, it would still work.
Yeah.
It just wouldn't get you the point of discontinuity.
Okay.
And then you wouldn't know which one was an asymptote. The one that cancels off is the point of discontinuity. The one that's left behind is an asymptote. So we know we have a point of discontinuity. Good thing we have Max here to translate because I was so lost and he was not. See, good question. I just sucked at understanding it. Okay, point of discontinuity was at -1, comma something. How do I get the something? Yeah. Yes, so I'm going to go f of the simplified one, right? F of -1 equals -1 minus 5 over -1 minus 4, which is -6 over -5, which is 6 over 5. So I know at -1 and 1.2, there's an open dot. How can I sketch the rest of the graph? From your table of values. So sketch the rest. When we want to sketch this, what do we type in? The simplified version or the original always? Original, because you're trying to draw the original, right? Yep. Yep. Make sure if you're not putting this in fraction, make sure you're putting it in brackets. So what you want to make sure you don't do is fill in that dot, right? Make sure you have the open dot on the point of discontinuity. That's what your graph would look like. It would look like a rational with an open dot, correct? So when you simplify the equation, if all that's left is a line, after you cancel, you have a line with an open dot. If after you simplify the equation, you have a rational with an open dot. That's it. Okay? Now the rules we used were if the numerator is smaller than the denominator, it's always 0. If the numerator is the same as the denominator, it's a fraction of what's in front. Calculus will explain why that's real, not just we told you to memorize it. Okay?